Yes, my name is Néstor Pérez-Arancibia. I am an experimental roboticist. My research focuses mostly on micro-robotics, cell robotics, and feedback control. Okay, so the water strider was inspired by water striders. In the past, some of my robots have been inspired by animals. For example, the B++ was inspired by bees. The Raw Beetle was inspired by beetles. But some of these robots are just the product of our imagination. That's the case of the Minibot, right? So we design and develop the Minibot just to show that we can do very small things that can crawl. So an actuator is a device that takes energy and gives you force or torque, right? So then SMA materials are materials that you can program to, for example, oscillate periodically, so they give you actuation. So in the case of chain memory alloys, if you make wires, for example, of chain memory alloys, if you make them smaller and smaller, you also make them faster and faster, and that's related to heat transfer. All right, so chain memory alloys, for example, you can make wires, and then you can program those wires to come back to a pre-programmed shape if you use heat. Then if you use periodic heat, right, you can make this material, this wire, for example, to oscillate and oscillate, so that gives you actuation. That's something that is going to take energy, heat, and it's going to give you force, right? So you can put masses here and going to move those masses, for example. So in the case of materials like this, so if you make wires of chain memory alloys, right, the smaller you can make those, the faster is the heat transfer. So just by making them smaller and smaller, you make them faster and faster because you increase the rate of heat transfer. Okay, so there are many hundreds of applications, right? The most popular that people talk about, even in science fiction books, are artificial pollination, right? So pest control, search and rescue, biological research, monitoring of water reservoirs, surgicals, and other medical applications. So I think that the best thing that we could do is to save the natural pollinators, say bees or flies and so forth. This is the smart thing to do. However, you can think of scenarios in which makes complete sense to have artificial pollinators, right? A famous example is almonds in California. They moved bees from Massachusetts to pollinate almond trees in California, right? That makes no sense, right? It makes more sense for us, right, to have robotic bees or robotic flies that do that job instead of disturbing the ecological system, bringing, millions of bees from Massachusetts to California. That makes no sense to me. So the big problem and what is next for us in our lab is to make these robots completely autonomous from the power and energy perspective. Then we want these robots to function for many hours. And the main technological limitation here is that the energy density of batteries is very small. So then we need new technologies to use other sources of energy, for example, fuel, or we need simplified electronics that can allow us to make these robots completely autonomous and function for many hours, right? So in my lab, we have two lines of research. One line of research is using other sources of energy, not batteries. And the line of research related to this paper is to make actuators that can function with very simple electronics at low voltages. And that's the case of these two robots, the water strider and the Minibot, that we can excite those with small voltages and with very simple electronics. Yeah, that's an interesting one because when I was a kid, I wanted to be everything. I like dinosaurs and I consider to become an economist and stuff like those. So by seeing this curiosity, the desire of exploration, and I like to create new things, to imagine and realize things that nobody imagined before. That is the coolest part about being an engineer, I think.